Hello viewers, welcome to MAGESH chemistry classes. In this presentation, we are going to discuss CSIR NET TNSET TRB Assistant Professors 2024 examination. Our channel continuously uploading the topics in the TNSET and TRB Assistant Professors chemistry part, theory and multiple choice questions explanation. This presentation included the probability and the normalization concept in the quantum chemistry. Here we are going to discuss about probability and what is normalization and what is the significance of normalization, how to normalize the wave function, and to find out the probability of the particular wave function within the range. Let us move into the question part. The first topic is probability. Here, the wave function does not determine the exact location of microscopic particles like electron during the motion in any system, according to Max Born. That is, we cannot correctly calculate the wave function of the particular matter wave while they are in the motion. Therefore, the alternative probabilistic region in the form of mathematical expression. The mathematical expression is the probability P is equal to integral over a range psi into psi star. That is the square of the wave function dot of. And the range is A and B. So A and B is the desired region in which we have to determine the probability. And psi is the wave function. The psi star is the complex conjugate. The d tau for 1D box, it is dx, and 2D box, it is dx dy. For 3D box, it is dx dy dz. For the hydrogen-like atom, for the polar coordinates, d tau is considered as r square dr sine theta, d of theta and d of psi. And the complex conjugate is, if the wave function is in the form of a plus complex number ib, the psi star is equal to a minus ib. So this is a complex conjugate. So probability is nothing. It gives the probabilistic region in the form of mathematical expression. That is, simply say it is a chi-square. Okay. This is about the probability. The next topic is normalization. A wave function used in the quantum mechanics should be normalized. Whatever the wave function involved in the quantum mechanics should be normalized. A function is said to be normalized when the probability of this binding the electron over the required space of the system is equal to 1. So according to normalized condition, the probability P is equal to the integral of, with a particular range, the psi square dx is equal to 1 in case of 1D box. So this is the normalization. So this is the probability. This probability should be 1. So this is called a normalization. If psi is not normalized, that is not equal to 1, we have to make it normalized for the purpose of this quantum mechanics. To understand some of the MCQs we have discussed here, the first one In the context of wave functions in quantum chemistry, what does normalization ensure? So what is a normalization in the quantum chemistry? Sure about the concept. The answer is the probability of finding particle is unity when integrated over all the space. So this is the answer. The second one, which of the following statements regarding normalization in quantum chemistry is correct? The normalization ensures that the integral of the square of the wave function over all the spaces equal to 1. So it is a similar type of MCQs we will encounter in the competitive examination. See, if the wave function is not normalized, what effect does it have on the calculated probabilities in quantum mechanics? It distorts the probabilities. Our answer is D. Then, which of the following is a consequence of the normalization wave function in quantum chemistry? It ensures wave functions represents in the physical state with a finite probability of the occurrence. The next our topic is how to normalize the wave function. First of all, we will determine the integral of psi square dot tau. If the value is equal to 1, it is normalized. In some cases, it is not equal to 1, then what we have to do? The value is reversed, taking square root, and then attached to the function. Let us discuss some of the questions related to the normalization concept. First exercise, check the function psi x is equal to x is normalized or not between the limit 0 to 1. If not, normalize it. The given function is x is a function. We have to, the integral of the square of the wave function within the range should be equal to 1. See, the integral limit 0 to 1. Wave function is x, complex conjugate, and psi x dx is equal to 1. It should be equal to 1. Okay. Now you find the value of this one. So this is equal to limit 0 to 1, and the wave function is x into x into dx. So this is equal to x squared dx, and this is equal to x cube by 3, and the limit is 1, 0. Correct? So differentiation of the x squared. So according to limit, it is 1 by 3 minus 0 is equal to 1 by 3. So this value is not equal to 1. So the function is not normalized. Correct? Then we have to normalize. For normalized condition, what is the step involved in it? First, we will determine the square of the wave function in the integral value, and equal to 1 it is normalized. Otherwise, it is not equal to 1, then the value is reversed, taking square root and then attached to the function, that is normalization constant n is equal to 1 by square root of this value. Okay. So this is a normalization part. So the value is reversed, that is 1 by 3 is reversed, that is 3 by 1, and taking root 3. The root 3 is attached to this wave function. So the given wave function psi x is equal to root 3x. This is a normalized wave function. This is the normalized. Suppose this function is normalized or not, we have to check again. That is 0, 1. The root 3x is attached to the normalization constant, and root 3x into dx is equal to 1. So this is equal to 0, 1. It is 3x squared dx. So this is equal to 3 into x cube by 3, 1, 0. It's equal to 3 into 1 by 3 minus 0 is equal to value is 4. Now it is normalized. So this function is normalized. Okay. So in this way, we are going to normalize the wave function. The first wave function is equal to sine by x. For normalization, it is 0 to 1 limit sine pi x into sine pi x dx. So this is equal to sine square pi x into dx. So integral part of sine a squared x is given by the formula sine squared ax. So instead of pi there is a term a is present. So this is equal to 1 by 2 x minus 1 by 4 a into sine 2ax. So this is a formula. We can expand this. This is equal to 1 by 2 x, the limit 1 and 0, minus 1 by 4 pi. Okay. Here sine 2 pi x minus 0. Limit is 1, 0. This is equal to 1 by 2, x is equal to 1, upper limit, and it is minus 1 by 4 pi. Sine 2 px, sine 2 pi x minus 0. Sine 2 pi, this value is 0. Sine 2 pi, that is 180 degree, this value is 0. So this is equal to 1 by 2. This is not equal to 1. So the sine by x is not normalized wave function. In order to normalize, the value is reversed, taking square root and attached to the wave function. Okay. Suppose this wave function is going to be normalized. What is that? The 1 by 2 is reversed, it is 2, and then it is square root. Then it is added to the wave function, that is pi is equal to root 2 into sine by x. This is the normalized wave function. Clear? The next question is the wave function x equal to 1 by x between the limit a to b. The given wave function, the psi x is equal to 1 by x. So within the limit integrating a to b, 1 by x into 1 by x dx. We have to find out the value. So it is a b 1 by x square dx. This is equal to minus 1 by x b a. Limit. Clear? That is x power n is equal to x power n plus 1 by n plus 1, or it is reverse, x minus 1. And this value is equal to 1 by minus 1 by b plus 1 by a. So this is not equal to 1. So you can write it is pa and it is b minus a. So this is the square of the integral part. So it is reverse, and so it is ba by b minus a, and it is taking square root ba by b minus a and attached to the wave function, that is psi x is equal to square root of ba minus by b minus a into 1 by x. So this is a normalized wave function. Okay. So up to this we have discussed what is normalization, how to normalize the wave function. Then the another topic is to find out the probability of the particular particle between the limits 0 to L by 4 in the region. Okay, so this is another model question. For that you have to normalize and find out the values. And this is a particle from one-dimensional box. So simply what is the particle is not given. It is a particle in one dimension. 1D box, the wave function, the derived wave function is given by the formula 2 by L, root 2 by L, sine n by x by L. So this is the wave function of the particle. You have to find out the probability of the particle between the space 0 to L by 4. L is the length of the box. So what is the formula to find out the probability? That is, probability is equal to the limit L by 4, 0, and you have to square the value n by x by L square dx. So this is equal to 0 to L by 4. This value is taken out, so it is 2 by L. It is sine square n by x dx. By expanding this one, it is 2 by L. It will be 1 by 2 x, the limit 0, L by 4, minus 1 by 4 pi sine 2 by x by L, and limit is L by 4, and it is 0. So by expanding this integral, you have the result like this. The next step, it is simplified. This is equal to 1 by L, and this is x L by 4, 0 limit, minus 1 by 2 by sine 2 pi x L by 4, 0. Again, just simplify. Then by expanding, that is 1 by L. So it is x, so it is L by 4 into L by 4 value x minus 0. And this is minus 2 by is equal to sine 2 by into L by 4 minus sine 2 by 0. This is equal to 1 by 4 which is equal to 1 by L. So L cancel, it is 1 by 4 minus 1 by 2 by L. Here it is sine pi L by 2. Next it is equal to 1 by 4 minus 1 by 2 by. The L is cancelled. And the sine n value is equal to 1. So this is 1 by 4 minus 2 by. So the probability is equal to 1 by 4 minus 1 to 1 by 2 by. So this is the region where you can find out the particular species. Okay. So it is another type of questions. Calculate the probability of finding the particle between 0 to L. The range is given. The space is given. You have to find out the probability. Here the normalization concept, you have to normalize the particular wave function, and the method to normalize the given wave function. So this is the end of our presentation. I hope that it is useful to you. Thank you for watching this video.